particular solutions. Finding particular solutions. Okay. Given the initial condition y of 0 equals 1, find the particular solution of the equation. Should I wait a minute? Let everybody get back on track? Okay. Find the particular solution of the equation. xy dx plus e to the negative x squared times y squared minus 1 dy equals 0. We will now. No. Hey.
No, it's a flippin' chart theater.
Okay. So this is a little bit different type of integration. Okay. What I want to do is I want to separate them again, but it's obviously going to take a bit more work. Okay. There probably are a couple ways to do this. What do you think we should do first? You're going to put the xy dx on the other side? Okay, which is going to leave me with e to negative x squared y squared minus 1 dy equals negative xy dx. Okay, so now I got my dy and dx's on separate sides, which is, we're on the right track. Alright, now what do I have to do? Divide each side by y. Okay, so those go. Here we are. Now what? Divide by e to the negative x squared. So I get y squared minus 1 over y dy equals negative x dx over e to negative x squared. Looks messy, huh? Looks like no fun at all. Okay. Notice I have e to the negative x squared. How can I bring that e to the negative x squared into the numerator? I need to multiply. Yeah. Okay, so we're going to bring this up, which becomes negative x e to the positive x squared. When I push it up to the other side of the fraction bar, that exponent changes signs, right? So I get this. Now I also want to rewrite y squared minus 1 over y dy. How can I rewrite that? y minus y to the negative 1, or y minus 1 over y dy. That works for me. Are we separated? Divided? Are we separated? Yeah, absolutely. What do I need to do now? First we separate, then we integrate. So, I'll throw some integration signs in there. You don't believe in integration? Good for you. Keep going then. Alright, so, what do? We're definitely going to have to use a u substitution for that negative x e to the dx squared, right? For sure. But this first one's not that bad to integrate. What do we get when we integrate that? Good. Y squared over 2 minus ln of the absolute value of y equals, and now here comes the trickier part of the integration. Okay. What do you think we're going to let u equal? X squared. Okay. Then what? What happens? Why don't you go ahead and do that and see what you get? It's really not that bad. Let u equal x squared. What's du equal? 2x, so what's dx equal? Du over 2. X. Okay, so what's going to cancel? My x's, which is going to leave me with negative 1/2 not an integral, just e to the x squared, that's a weird x, plus c. Okay? All right. Now, we have an initial condition, right? We have y of 0 equals 1. That's our initial condition. When I plug in x equals 0, y equals 1, what do I get for c? I'm going to take it and put it right in for there. X equals 0, which is going to make me have, what over on the e side? If I have e to the 0 squared, what's that become? Negative 1/2 plus c. And how about over here if I plug in 1 for y? What's ln of 1? 0. Okay? So I wind up with 1/2 equals negative 1/2 plus c. Got to get all the constants over to one side. What do I get? What's c equal? C equals 1. Very good. C equals 1. So, we have a general solution. This is our general solution. What does our particular solution become? This big long thing plus 1 instead of plus c. Okay, so I get y squared over 2 minus ln of y equals negative 1/2 e to the x squared plus 1. That is our particular solution. Okay? Yeah. So we can very easily go from a general solution to a particular solution just by having that one initial condition. All right? What time is this class on? 12 after? Not until everybody's done. Okay, so we're going to do a little bit of summary ball.